back with another problem, and today's problem is mobile numeric keypad. So this is an interesting problem, and today we are doing most probably our day 3 on number system analysis. And today's problem statement is very interesting problem statement. We will be given a number n, and we have to find the possible sequences of the length n that you can create by pressing the buttons. Okay, so let's come to the problem illustration part. So I'm going to quickly present my screen. Yeah. So what this problem is all about is first I'm going to write this. This problem is on say number system. So number system. This is one of the topics of this problem, number system, and this problem basically deals with two-dimensional arrays and dynamic programming. So I can write 2D arrays and dynamic programming. Okay, so this is an important concept of DP and dynamic programming which we are going to learn, and this is a medium-based question. Okay, so what are the things which we should know? Why DP, and why we can't solve this problem? So first let's analyze this problem. Okay, so first I'm going to have a mobile number keypad. Okay, so in the number keypad I'm going to quickly store the numbers. Okay, 1, 2, 3. Okay, similarly 4, 5, 6, 7, 8, and 9. You know that there are only 9 digits possible, right? And also there are possible other digits like star and hash, which we long press this keyboard to get this particular keyword. So you can see this is a keypad. So what's the keypad of a mobile? Okay, so what we are going to try and analyze, we are going to find the length of the longest sequence possible when we press a particular key. So what I can write is our goal as whenever you're doing a particular problem statement, my particular idea is like that you should always write your goals in a paper and how you're going to deal with this problem. So for this goal, we are going to set the goal as the longest sequence of length for a number pressed. Okay, so if I press the number, say num equals to 1, so what is the longest possible output will be? So the output will be equals to 10. So now I'm going to explain. So you will say like, Arnab, I didn't understand shit about it. So what is actually there inside it? Okay, so say for example, whenever you're pressing a digit, say 2, and it's like when you're pressing it, it's a sound is beep sound is coming, and again you're pressing the digit 1, again a beep sound is coming. So we have to create such a number, say for example such a number whenever such a possible length of the number which has a 2 in it. So it can be 1, 2, 3, 4, 5, 6, any other digits. Like when you're pressing a number like that, you have to follow the sequence of this length, the total count of the times when you're pressing a number. So you are giving a mobile number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or you're giving my phone number like 7, 8, 9, 4, 6, 6, 7, 4, 2, 2, 3, 1, 1, 2. So whenever you're pressing this 2 digit, how many times, how many possible length the 2 can be? So this you have to find the total number of occurrence, okay, you have to find the occurrence as well. So we have to do this with dynamic programming. So why dynamic programming? So why DP? Let's answer this question. Why DP? Because you will be saying this, Arnab, I can solve this problem using a loop, right? So how many loop are you going to use for a matrix of n cross m? So this is a matrix of n cross m. Okay, this is a matrix of n cross m. So it's a pretty big matrix, right? So you know that there are like 3. So there is like 3 rows and columns, and there can be, say, infinitely many number of possibilities. Even for a small digit like 1, it has 10 outcomes. For 2, it has 36 outcomes. So if n equals to 2, the outcome becomes equals to 36. I will explain this. Why 36? But before that, why we are using DP? Because DP has some characteristics. It helps to efficiently solve subproblems. It prevents repetition. So whenever you're doing something with DP, it will prevent repetition. It will help to efficiently solve the subproblems. You can see that n equals to 2 as outcome number 36. So in case of a Fibonacci series, you can see that we have used DP in order to find values which can be really long to compute. We can also write DP used for solving problems with higher range, Okay, so let's come and analyze this problem. So over there I have quickly written this problem statement, and it's a long problem statement. So first we can see is that we have been given a mobile numeric keypad. Okay, so this is a numeric keypad. The keypads have rows and columns. So I will be the rows and J is the columns. J is the column. So you can move in this direction or this direction, right? So these are the possible movements. The movements, you can move to the top, you can move to the right, you can move to the bottom, you can move to the left. These are the possible movements. We have to use an algorithm. We have to use an algorithm where initially, before making a mobile keypad, you have to store the digits, right? So in the CAD keyboard, we are using a CAD function. CAD double means 2D array. So this means a 2D array. So in this 2D array, we are storing in the keypad the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and star and hash and 0, right? What else is there? The directions. So the directions are, let me write the directions. -1, 0, 1, 0. Okay, 0, -1, 0, 1. So I can write it like that: top, down, left, right. So you can move the directions like this. Initially we have to set the direction pointers like that. After that we are using a get count method. If our value of the n is less than equals to 0, say for example you are not pressing anything, over here there is an input, right? So this input is user defined. User will pass the value over here in this input. So if the user is not passing any value, what will happen? That is the case. So I will write it over here that n equals to 0. For n equals to 0, what can be the case, right? So let me just adjust the thickness. Yes. So for n equals to 0, we are going to return 0. We are going to return a 0, right? Okay. Now let's check the case for n equals to 1. What happens in n equals to 1? I have told you for one scenario there can be total of 10 possible digits from 0 to 9 and then 1. So means 10, right? So there are total possibilities of 10 combinations of such length. Now we are creating a DP table, but before creating a DP table we have to initialize this word DP. It can be any variable. It can be any variable of your choice. Any variable of your choice. This is the size of the DP table, where the row and the column is there. Column has been 10 elements is the size, n plus 1 is the number of digit plus 1. So digit given by user plus 1. We are traversing a loop from 0 to 9 because the digits can be from 0 to 9. So be very careful, we are traversing a digit from 0 to 9. We are initially in the digit, we are storing row and column. We are setting the column, we are taking the column values and initializing all the column values with 1, with I. So initially for first row, say for first row, there's an element. So we are initializing every element with 1. Okay, we are filling the table. Now we have to fill the table carefully. Since we have iterated over the value 1, here the value 1 has been checked. We are going to start our loop by filling the DP table from 2. And the loop will run till n and I++. Similarly, the DP table has the digit counter. So this is the digit position mover. Digit is moving from 0 to 9 and the digit is going D++. Then we have to store the positions. So what I can write it over here, store position, store position in the pos array, in the position array. So in this array, you will be storing all the positions. But before finding position, storing the position, we have to make a method which has a find position. So we have to store the position. How will this function store the position? We have to find the position, and in this we are inserting the digit. We have to insert the digit and we have to find the position of the digit. Okay. Then again we have initialized the initial value of the length and digit equals to 0. Now we are going direction wise rows and columns. So this will be in our DP table. So in the case of a maximum triangle problem, then dungeon problem, and then saving the queen problem, we have always used a DP table. So DP table is like a rough table, where you store the values, rows and columns, okay. So we have to store the values I, j in this order, and there will be some values. These values will be stored based on the direction. So you can move on this direction, you can move on this direction, you can move on this direction, and you have to initially reach to a particular direction. You have to find the shortest possible ways, and all those things can be concluded using a DP table. So first what we are going to do in this problem statement, we are going to take the first position. In the digit we have to take the first position and the first direction. That's why we are using 0 and 0. In the column position we are going to take the position number of 1 and direction of 1. Okay, now we are checking is it a valid row and column. So of course we have to even check the row and column is a valid row, because we have given a condition that the row and column has to be less than equals to 10. It can't be greater than equals to 10. It can't be large. It can be a 0. Okay, so we have to check these things. That's why we are using a is valid. So is valid, what does is valid return? Is valid returns true or false, since it's a Boolean function, right? So after that we are taking a new digit equals to keypad, new row and column minus 0. So what is minus 0? If you check carefully, I have stored all the numbers in ASCII formats in 1, 2, 3, 4 in a character array. So when you are taking a digit in a character array and you are minus 0, that means 0's ASCII value. So I'm giving you a formula. Okay, formula. So any digit in character minus 0 returns that digit's ASCII value, say digit ASCII value is x and 0's ASCII value is say 48, minus, if you do this you will get the digit itself. So say for example you will get the digit itself. Okay, similarly you are getting the digit by using the keypad. You can, if you want to know more about how I'm getting, you can Google this topic ASCII. It is nothing but the how the numbers in the string, suppose this is a string A, B, C, 1, 2, 3. So in the string, 1 has an ASCII value of say 49, 2 has ASCII value of say 50, and 3 has ASCII value of say 51. So if you say 0 has an ASCII value of 48. So for finding the digit 3 or extracting the digit 3, you can see clearly 51 minus 0, which is 48, we're getting a 3, which is equals to the digit itself. This is how I'm proving you. Okay, why I'm getting keypad function over here. Okay, so after that we are adding the string at the same digit, add string at the same. What if someone is pressing 2 multiple times? What if that person is pressing 2 hundreds and hundreds of times? In that case we have developed a formula dp of length of digit plus equals to len minus 1 and digit. Now we have to add the sum of all sequences, which I told we have to use a total counter. So this is a total count variable which is used to store the sum of all digits, and which is initializing and returning total count. Now we are using finding position. So for finding position we have taken array and then we've passed the key over here. So we have taken the char array, and the char array has the particular key. It's traversing through the rows and columns, and it is checking whether I and j is equals to that particular character present, which is 2. Then we are taking the count plus equals to. Okay, also in the previous question I have already explained, previous explanation I have told you that there is a is valid function. So is valid function is checking whether the rows is greater than equals to 10 and the row is lesser than equals to the keypad length, which is m cross n, so it has to be less than 3, right? So these are the conditions you have to check. Or we have to also, another condition we have to check whether digit is valid, whether the digit is hashtag or not. So if it is a hashtag, it is not a digit. That's why we have used not equals to over here. Okay, finally we are using public static void main. We are passing 3 as the digit and n plus get count is the name of the function. Now we are going to come with the coding and explanation of the part. So if you check the coding part, if you check the question, there's a numpad given over here, 1, 2, 3, 4, 5. If you see the number of possible combinations for the number 1 equals to 10, so the number of possible combinations are 0 to 9. Okay, for n equals to 2, you can see the possible numbers are 0, 0, 0, 8, 11, 12, 14, 22, 21, 23, 25, and so on. So if we start with 0, and valid numbers will be 0, 0, 0, 8. So means you can make a phone number like this, like 0, 0, 0, 0, 2, like that. So if you check it, like they are saying that there will be a total count of 36. Okay, there's a total count of 36. So we have to do this with on and on. So on, time complexity, can only be achieved if we use dynamic programming. Okay, so next we are going to see the code and we are going to analyze the code. Okay, so first, while analyzing the code, you can see we have taken a class solution. In that we have taken a character keyword. So be very careful while you take the code of this particular snippet. So first you have to take a private static find and character keyword. Inside that you have put all the characters. After that we have taken the directions in the directions array, up, down, left, and right, to store the initial directions. Now this is the get count method which is used to get the digits. First we are checking if the number is lesser than equals to 0, then we will return 0. If it is 1, we are going to return 10. In the dp array we are going to store the count of the sequence of the length I ending at the digit j. Okay, we have to then initialize we have to initialize the base cases, right? So base case is sequence of the lengths and the digits themselves. So we have to take I value and we have to initialize all the rows with 1. We have to fill the DP table. We have to start with length 2 and the length will go to n and n plus plus and digits so on. We have to find the position using the find position method. Length and digit are been found. For I and rows and directions, the new rows and columns are been added. Then we have to check whether it is valid. After checking, we have to staying at the same digit. We have to find the total count of the sequences. We have to also use a function find position in the keyword. And lastly, we are checking whether the keyword is valid or not. Okay, so you can go to the code slowly and you can write this code, and I'm hoping this code will work. Let's submit our solution. So we have successfully completed today's problem statement, and it was an interesting problem statement on DP. So once again, I'm going to show you the code. So this is the code with the character keyword, the directions over here, the get count method over here. Okay, after that we have to fill the DP table over here. Then we have to do the sum of the all sequences of the length n, and once that is done, we can find the position using this. There's a private boolean function is valid to check whether the particular keypad constraints are valid or not, whether it is hashtag, whether it's 0 or not equals to star, and it has to be lesser than, greater than zeros and all this stuff. So we are looking forward to solve more problems on DP. Thank you. Stay tuned.